1676, a Dutch cloth merchant named Antony van Leeuwenhoek pointed a homemade lens at a drop of pond water, and he saw something no human being had ever seen before. Tiny creatures, darting, spinning, vibrating around, thousands of them in a single drop of water. He called them animalcules. He wrote to the Royal Society of London. Their response? Prove it. They assigned their top botanist, Nehemiah Grew, to reproduce his results. Grew failed. Robert Hooke failed. Then Hooke tried again. He failed again. But on his third attempt, Hooke finally saw them. But even after people could see these things, the scientific establishment spent the next 183 years arguing about whether they were actually alive. 183 years. I think we're making the same mistake now, just in the other direction. Not with the microscopic, but with the macroscopic. And a biologist at Tufts University named Michael Levin may have already given us the key to seeing it. Welcome to our Fractal Universe. I'm Chris Lato, and this is episode 6 in the Our Fractal Universe framework. They said microscopic life was impossible too. I'm sure you've heard the saying, those who don't know history are doomed to repeat it. Well, do you actually know this history? I didn't before researching for this video. The history of microscopic life played out in 3 stages, and I want to walk you through them because the pattern is pretty similar. Stage 1, that's not life, that's just stuff moving around. Leeuwenhoek sees bacteria in 1676. At the time, he's absolutely certain that they are alive. He watches them reproduce. He tracks different populations over days and weeks. He tests different water sources. This man was meticulous. He even cleaned his glass containers with snow water to avoid contamination. But the scientific establishment had a problem. These things were too simple. They lacked the structures that real living things had. No organs, no limbs, there was no visible complexity. The great Christian Huygens wrote to the Royal Society and essentially said, I tried to see what Leeuwenhoek sees, and I couldn't. I think he's imagining things. So the objection wasn't, we can't see them. After Hooke replicated the observations, everyone could see them. The objection was, for 183 years, these can't be alive. They're too simple. Life requires complexity. It needs organs and structure and purpose. These are just bits of matter bouncing around in water. Does this sound familiar? Stage 2. Okay, they exist, but they just appear out of nothing. So this stage lasted over a century, from roughly 1745 to 1859. The debate shifted to spontaneous generation. An English priest named John Needham boiled chicken broth. He sealed it in a flask, and microbes still appeared. His conclusion? Life springs from non-matter. It just happens. Then an Italian scientist named Lazzaro Spallanzani showed Needham hadn't boiled long enough. Some microbes survive. Needham's side fired back. They said, you destroyed the vital force in the air. You boiled it too hard. So you boiled out of the air the vital force. So this went back and forth for 114 years. You had the claim, the counterclaim, experiments that both sides interpreted differently. So nobody could settle it because they were arguing about mechanism without a clean test. Stage 3, one elegant experiment ends the debate. Then in 1859, Louis Pasteur, if you've heard of him, designed his famous swan-neck flask. The S-shaped neck lets air flow freely into the broth, so nobody can claim that you destroy the vital force out of the air. But the curved neck traps dust particles carrying microbes. They settle in the bend and they can never actually reach the broth. So the result is that the broth stays sterile indefinitely. If you tilt the flask so that the trapped dust slides down into the broth, then you get instant microbial growth. So the experiment was simple, it was elegant, it was falsifiable. One experiment and 183 years of debate collapsed. So here's what I want you to notice about that timeline. It wasn't that the evidence was lacking. Leeuwenhoek had the evidence in 1676. They could literally see it. The problem was the framework. People couldn't accept that life could exist in a form that didn't match their existing definition. It was a perception problem. They were pattern matching against what they already knew. Animals with organs, plants with leaves. And anything that didn't fit into that template got dismissed as not really alive. Act 2, the same mistake in reverse. So now let me ask you something. What happens when you apply NASA's official definition of life, a self-sustaining chemical system capable of Darwinian evolution, to a star? It's just a simple sentence, but it contains 4 functional requirements hiding inside it. So let's be rigorous and apply each one to a star one at a time. So requirement number 1 is metabolism. That's self-sustaining energy transformation. A star converts hydrogen to helium through nuclear fusion, releases energy continuously for billions of years. That's a self-sustaining reaction. The substrate is definitely different, so it's nuclear rather than molecular or chemistry. But the function is identical. Take in new material, process it, release energy, maintain yourself far from equilibrium. So there's one objection I should address directly. NASA's definition says chemical system, and nuclear fusion isn't technically chemistry. It's nuclear physics. It's not molecular. So this is a fair point and the main skeptical argument. But listen to this. NASA's own astrobiologists have debated whether the word chemical was intended as a functional placeholder rather than a literal constraint. Gerald Joyce, who helped craft the working definition, has acknowledged that it may need to be substrate neutral. The functional requirement, sustained energy transformation, is what matters. Stars pass it. Requirement number 2, reproduction and inheritance. So when a massive star dies in a supernova, it seeds the surrounding gas cloud with heavy elements. That enriched cloud collapses to form new stars, to birth new stars. Those are the words we used: birth, death, lifespan of a star. That enriched cloud collapses to form stars with higher metallicity than their parent. The metallicity distribution of stars in a galaxy follows a pattern that looks remarkably like inheritance. Younger stars carry the chemical signature of the older stars whose deaths created them. That's why we have population 3, population 2, population 1 stars, if you've heard of that. This is inheritance, and we can tell from the metallicity. Requirement number 3 is homeostasis. It's a prerequisite for being self-sustaining. Stars regulate themselves through a feedback loop. If fusion increases, the core expands, which cools it, which slows fusion. If fusion decreases, gravity compresses the core, which heats it, which, guess what, increases fusion. This is homeostasis. It's the same principle as your body maintaining 98.6 degrees. The mechanism is different. Gravity and radiation pressure instead of sweat glands and shivering, but the functional pattern is identical. And finally, requirement number 4 from NASA's definition is Darwinian evolution. Stellar populations change over cosmic time. Each generation has different properties than the last. This is driven by the environment in which they form. Population 3 stars The first generation were pure hydrogen and helium. They lived fast. They died young. They're like rock stars. Population 2 incorporated those heavy elements. Then population 1, like our sun, incorporated even more. Every heavy element in your body was created in a previous star. The population changes over time in response to the environmental conditions. That is what Darwinian evolution means at the functional level. You have heritable change in population characteristics across generations. So now I already know the objection. Sure, it'll already be in the comments before I've even gotten to this part. But the objection will be, that's not life. That's just physics. But you have to realize that's exactly what they said about the Leeuwenhoek Animalcules. They said, that's not life. That's just stuff moving around in the water. Comes out of nowhere. And I do want to be honest with you guys. I know how that sounds. I know exactly how that sounds. But the objection isn't about evidence. It's about framework. And that's precisely what Levin's work changes. The Levin insight. Life is pattern, not substrate. And this was a huge paradigm shifting moment for me when I found Michael Levin. So Michael Levin is a biologist at Tufts University who works with bioelectricity. That's the electrical signals that cells use to communicate. His most famous experiments involve planarians. They're tiny, super cute flatworms that can regenerate from almost any piece. They can regenerate to the full original worm. You cut a planarian in half, the tail grows a new head. But here's the part that should stop you cold. That new head, with its brand new brain, retains memories that the old brain learned. The memory then isn't stored in the neurons. It's stored in the bioelectric field. That's the pattern of electrical signaling across the tissue. Levin took this even further. By manipulating those bioelectric signals, he created planarians with two heads and no tail. And here's the critical part. When he cut those two-headed worms and then let them regenerate, they grew back as two-headed worms. Think about that. So the DNA hadn't changed. It was the same DNA. The bioelectric pattern, the informational blueprint, had been rewritten, and it persisted across generations of regeneration. So what Levin proved through a simple, elegant experiment is that life's defining feature isn't the specific chemistry. It's not the DNA. It's the organizational pattern. It's the way information coordinates matter toward a goal. DNA is one way to store that pattern. Bioelectric fields, he proved, are another way. So it's the pattern that matters, not what it's written in. This is called substrate-independence. It means the same organizational principle can run on different hardware. Basically, you can software encode life. And once you accept substrate independence, which, by the way, is peer-reviewed, published, replicated science from a major university, then the question about stars and galaxies changes completely. You're no longer asking, do stars have DNA? You're asking, do stars exhibit the organizational patterns that define life? Metabolism, reproduction, homeostasis, evolution. They're all present. They're all documented. They're all running on nuclear physics instead of molecular chemistry. It's a different substrate, the same pattern. We even use the same words. Birth of a star, death of a star, lifespan of a star, populations, different populations of stars, star nurseries. Right. Act 3. Where are we now? So then where are we in the 3-stage history? So I think we're in stage 2. We see the patterns. Stars metabolize. Galaxies respond to stimuli. Stellar populations evolve. We name them populations. We have life, birth, lifespans. The mathematical laws that govern biological organisms, Cleaver's law, quarter power scaling, metabolic rate, proportional to mass to the 3/4 power. some type of power law scaling appears at every scale we've measured, across 42 orders of magnitude. Stars have a known power law if their mass related to their lifespan. It's different from biological organisms, but like we've mentioned, the substrate is different. The physics are going to be different. The scale is vastly different. But the establishment says that's just physics. Just like they said, Leeuwenhoek Animalcules were just matter in motion. The objection isn't about evidence. It's about framework. It's about the perception. It's about your fundamental assumptions. Our current definition of life is implicitly substrate dependent. It requires life as we know it. It's the same issue we had not recognizing microscopic life because we could see it. Now we say chemical system, and we mean molecular chemistry. We say evolution, and we mean DNA mutation specifically. But NASA's definition doesn't actually require DNA. It doesn't require carbon. It doesn't require cells. Those are assumptions that we bring to the definition, the same way 17th century scientists brought the assumption that life requires organs and limbs. Michael Levin stripped that assumption away at the cellular level. His amazing work proved that you don't need neurons for memory. You don't need a brain for intelligence. And you don't need DNA for inheritance. You need organized information, coordinating matter toward a common goal. Think of cancer. It's living, but it doesn't have the same goal as the rest of your body. So the question we're asking on this channel, and the question my book is asking, what if that principle scales up? What if the same substrate-independent organizational patterns that make a cell alive, that make a flatworm intelligent without a brain, that make an ant colony behave as a single organism, what if those patterns don't stop at the boundary of what we can see with our eyes? So let me know what you think in the comments, because the one thing worse than being wrong about this would be being right and not saying anything. See you next week. Have a great day. Peace.